Welcome to A-Level and AP Physics. In today's lesson, we will discuss some typical type of questions on radioactivity from Specimen Paper 1 for 2022 exams. For question number 38, it is given to us a radioactive nucleus is formed by beta minus decay. This nucleus then decays by alpha emission. We need to find out which graph of nucleon number N plotted against proton number C shows the beta minus decay followed by the alpha emission. So first thing we need to understand is what is nucleon number. Nucleon number simply is equal to mass number. Nucleon number also you can simply understand is equal to number of particles in the nucleus, or you can say is equal to the sum of protons and neutrons in the nucleus. So nucleon number simply is mass number. Proton number is equal to atomic number. So proton number simply is equal to number of protons in the nucleus. So proton number is equal to atomic number. Now we need to understand first of all what is beta minus decay. So I will explain first of all what is beta minus decay. Imagine that we have nucleus X, atomic number of this nucleus is Z and the mass number is A, and this nucleus decays to an other nucleus by emitting beta minus particle. So let's say the new nucleus formed is Y, and this is formed by beta minus decay. So here we have beta minus particle. So in this case, proton number will increase by 1, but nucleon number, means the mass number, will not change. So simply what is happening in this case is one neutron changes into one proton, but mass number remains same. So neutron decays into proton. In case of beta minus decay, neutrino is also emitted. This is fast moving electron. So this is particle. So here anti-electron neutrino will be emitted. So electron anti-neutrino will be emitted. So we have seen here in this case, proton number increases by 1. So I will write down here proton number increases by 1, but nucleon number does not change. So we can say nucleon number does not change. So nucleon number remains same. So I will simply write it here. Nucleon number does not change. Now let's try to understand what is alpha decay. So I will be writing here alpha decay. For alpha decay, we will also imagine one nucleus. Let's say this is nucleus X. Atomic number of this one is Z and the mass number of this nucleus is A. And this decays to an other nucleus, let's say Y, by emitting alpha particle. So this is alpha particle. So when alpha particle is emitted, atomic number decreases by 2 and the mass number, means the nuclear number, this is decreases by 4. So simply we can write out here proton number. In this case, proton number decreases by 2 and nuclear number decreases by 4. So simply we can write out here nucleon number decreases by 4. Decreases by 4. So if you look at option B, in this case you can see proton number increases by 1. So proton number increases by 1 plus 1. The nuclear number does not change. So this one is true. Now if you look at the second, so this one is beta minus decay. So this is beta minus decay. Now if you look at this one, in this case you can see proton number decreases by 2 and nucleon number decreases by 4. So this decreases by 2 and this decreases by 4. And this is true for alpha decay. So this is representing alpha decay. So our answer for this question is B. This one is the right answer. For question number 39, we need to find out what are the structures of the proton and neutron in terms of quarks. Simply we need to find out what is the right quark composition of proton and neutron. So first of all, let's try to understand what is quark composition of proton. Proton consists of 2 up quarks and 1 down quark. So this is quark composition of proton. So simply we can say this one is proton. And the quark composition of neutron is neutron consists of 1 up quark and it consists of 2 down quarks. So this is quark composition of neutron. So simply we can write down this one is neutron. Now if you look at option A, this is telling us proton consists of one up quark, and this one is wrong. Next option is also wrong. But if you look at option C, it is given to us proton consists of two up quarks, one down quark. So this is right. But if you look at neutron, it is given to us it consists of one up quark. This is also right. It is also given to us it consists of two down quarks. So this is also correct. So the answer for this question is C. So very important one, you need to understand quark composition of proton and neutron. So proton consists of two up quarks, one down quark, and neutron consists of one up quark and two down quarks. For question number 40, we need to find out what is the charge of a top anti-quark. But there are total 6 types of quarks. Let's try to understand the charge on each type of quarks. In the first generation of quarks, we have up quark and we have down quark. In the second generation, we have charm quark and we have strained quark. In the third generation, we have top quark and bottom quark. If you look at these 3 quarks, means up quark, charm quark and top quark, all of them, they have the same charge. And the charge on them is equal to plus 2 by 3e. But now if you look at these quarks, means look at these 3 quarks now. We have down quark, we have strained quark, and we have bottom quark. All of them means all 3 quarks, they have the same charge. And the charge on them is equal to 1 over 3e. If you look at the first row, you can see up something higher, charm, also something better, top something higher. So they have the greater charge and positive charge. But if you look at down quark, down something not good, something low, strange also low, bottom something low. So they have the lower magnitude of charge and the charge is negative. So this is one way you can remember. Next thing we need to understand is anti-quark. Anti-quark has opposite charge. Anti-quark, for example, if we talk about anti-up quark, means up anti-quark, the charge on this one will be equal to negative 2 by 3e. If we talk about charm anti-quark, the charge on charm anti-quark will be 2 by 3e. And if we talk about top anti-quark, the charge on top anti-quark will be negative 2 by 3e. Now let's try to understand what is the charge on down anti-quark. So this is the symbol, we use bar at the top. So this is telling us this is down anti-quark. So simply this one is down anti-quark. So this is down anti-quark. And the charge on down anti-quark is equal to plus 1 over 3e. Simply you can say just opposite charge. Now if we talk about strange anti-quark, so we will use this bar at the top. This is telling us this is strange anti-quark. And the charge on this one will be equal to plus 1 over 3e. Now if we talk about bottom anti-quark, so we will use the symbol for bottom quark and we will use this bar at the top. So this means this is bottom anti-quark. And the charge on this one will be equal to 1 over 3e. Simply you can see opposite charge. So here we can also use bar here, means this is up anti-quark and this is charm anti-quark and this is top anti-quark. And this question was asking us charge on top anti-quark. So the charge on top anti-quark is negative 2 by 3e. So the answer for this question is C. So it's very important if you can remember the charge on up quark, charm quark, top quark, and on down quark, strained quark, and also bottom quark. Then anti-quark simply charge is opposite.